Good morning, students. As in last class we have done the line spectrum of hydrogen. When hydrogen spectrum is of hydrogen spectrum was observed, it is found that hydrogen spectrum contain some group of lines, and these groups are called, this series is called Lyman series, this series is called Balmer series, Paschen series, Brackett series, Pfund series. So the lines are classified into some groups, into some series, and these are named as Lyman, Balmer, Paschen, Brackett and Pfund series. Lyman series line falls in the UV region, Balmer series falls in visible portion, and Paschen, Brackett, Pfund series falls in infrared region. Now, one of the scientists called Rydberg gave one equation to determine the wavelength of different lines of different series. So how to determine the wavelength of different lines of different series? That wavelength you can determine by using the Rydberg formula. What was Rydberg formula? Actually, Rydberg gave one equation, and by using that equation you can find out the wavelength of different lines. And the equation is mu bar, wave number. You know wave number is equal 1 by lambda. Reciprocal of wavelength is called the wave number. This is equal RH, Rydberg constant of hydrogen, into R 1 by n1 square minus 1 by n2 square into z square, where z is the atomic number, and here R is called Rydberg constant. This is called Rydberg constant, and its value is 109,677 centimeter inverse. You can write this as 1.09677 into 10 to the power 5 centimeter inverse, and in numerical you can write 1 into 10 to the power 5 centimeter inverse also. So this is the value of Rydberg constant. What is Z? Z is atomic number. If the element is hydrogen, then atomic number you have to consider as 1. If it is other element, then that atomic number you have to consider. So R is Rydberg constant and Z is atomic number. What is N1 and N2? For Lyman series, N1 always 1 and N2 value may be 2, 3, 4, 5, etc. In case of Balmer series, N1 value always 2, N2 value may be 3, 4, 5, etc. For Paschen series, N1 equal 3 and N2 may be 4, 5, 6, like that. For Brackett series, N1 equal 4, N2 may be 5, 6, 7, like that. And for Pfund series, N1 equal 5, N2 may be 6, 7, 8, like that. So N1 and N2 value, N1 value depends on series. If the line correspond Lyman series, then N1 value always you have to consider as 1. N1 square means 1 square. If the line falls in Balmer series, N1 value always you have to consider 2, and N2 value it will mention in your question. If the line falls in Paschen series, N1 always you have to consider as 3, N2 may be 4, 5, 6, like that. So depending on the series, you will get the value of n1 and n2 value depends from which the line coming. I mean n1 represent lower energy level, n2 represent higher energy level. Actually, what is n1 and n2? In Bohr's theory you will get, actually atom contain number of cells. In case of first cell, n value is considered as 1. For second cell, n value is considered as 2. For third cell, n value is 3. For fourth cell, n value is 4. Like that, the cells are represent. As you have got K cell, L cell, M cell, N cell. This n equal 1 means it represents K cell, n equal 2 means it represents L cell, n equal 3 means M cell, n equal 4 means N cell. Like that, you will get different types of cell. In case of hydrogen atom, as you know, hydrogen contain only one electron, and that electron should be in the first cell, I mean in K cell. When this electron or when the hydrogen atom gains some energy, then the electron can jump from this lower level to higher level. I mean from first cell to higher cell it can jump when it gain some amount of energy. So suppose the electron jumps from n equal 1 to n equal 4 after gaining the energy. How much energy it gain, depending on that it will jump to higher energy level. So when the electron jump from n1 to n4, I mean when the electron jump from first cell to fourth cell, the electron cannot stay here for long time. Again it will come back to the ground state. Again it come back to the original state. When the electron jump from lower to higher level, it will absorb the energy. But when the electron come from higher level to lower level, it will emit the energy. And it will emit the energy in the form of light. And that is why you can see the spectrum. So that is why this n1 and n2 value means up to which cell the electron is coming, that represent n1. From where the electron is coming, that represent n2. I mean n1 represent lower energy level, n2 represent higher energy level. Suppose an electron is coming from n equal 4 to n equal 1 state. Then n1 value you have to consider as 1 because it comes up to 1, and from where it is coming, from n equal 4, so n2 value you have to consider as 4. So like this way, in Rydberg equation you have to put the value of n1 and n2. n1 means lower energy level, n2 means higher energy level. Now in every series whether it is Lyman, Balmer, Paschen, Brackett or Pfund series, in every series one line is called limiting line. Which line is called limiting line? Limiting line means that line in which n2 value is infinity. I mean if the line is coming from infinity level, then that line is called limiting line of each series. For Balmer series, suppose for Lyman series, the electron is coming from infinity and it comes to the n equal 1 state, then it is the limiting line of Lyman series. Suppose one electron is coming from infinity and it falls in n equal 2 state, then it belongs to Balmer series, and that is called the limiting line of Balmer series. So every series contain one limiting line, and limiting line means those line or that line in which n2 value is infinity. Thank you.